All right, class. Thank you so much for engaging with the warm-up just now. And so we're going to launch our second activity. And so if you look on your Desmos now, you should see screen 14. And so what we saw in the warm-up, it was all just equations in their raw forms, but now we will be connecting it to situations. And this is just like real life. Hello, Noreen, welcome. The link is right there in the chat. And so we're going to be starting our second activity of the day. So let's interpret equations in terms of a situation and relate them to a graph. We've already looked at these two situations before, and so hopefully they'll ring a bell. But what we'll be doing is first, you'll have 1 minute of quiet think time, and you're going to do a notice and wonder. And then I'm going to put you out into breakout rooms in pairs, and you're going to share your notice and wonders with each other. So make sure that you do have something before I put you out into those breakout rooms. Then I'm actually going to bring you back so that I can make sure there aren't any questions for the next part of the activity. And then I'm going to send you back out into those breakout pairs that you are with, and we'll have a whole class discussion. So everyone should be in your Desmos, and I'll be just voicing over there. And so here we have two graphs. I don't know if you remember, but this is with the water in the tank and the almonds and the dried figs. And so what do you notice? What do you wonder? Make sure you have at least one notice and one wonder in that box, and then I'll be sending you out into your breakout rooms. So go for it. All right, let's make sure everyone has something. Okay, I'll give you like 30 more seconds. We do have a new student here today, so just want to check in with her. Claire, are you able to see screen 15?
Yes, I'm on screen 14. Excuse me, 15. I'm looking at the graphs.
Okay, just waiting for your response there at the bottom, and then click submit.
Oh, thank you. I didn't know.
You're welcome. Yeah, I feel like you're noticing and wondering a lot. We just want to make sure that your thoughts are all captured. Okay, all right, great. So let me set up the breakout rooms. All right, here we go. So I'm going to hold you there for Ooh. It's going to say 1 minute, and then you'll have 30 seconds to come back. So you have 90 seconds to share with your partner what you wrote down for the notice and wonder. So here we go.
I'm gonna listen in.
Okay, cool.
Yeah, sorry guys, apologies.
Okay.
Claire, thanks for joining us to the
Yeah.
math team. Did you want to share out your notice first?
Sure. So I noticed the inverse relationship between, for instance, the amount of water in the tank and the number of minutes required. The more water is in the tank, the fewer minutes it takes. And my wondering is, because I've forgotten what happened in the earlier part of the lesson, what is happening with the water? What is the water being used for? And I was really curious about that.
Like inverse, do you mean it was like going down?
The graph is, let's see. So the more water there is.
And someone else didn't finish their homework. I had to update my grade book.
Hi, Joy.
Hi, did you already share?
We are prepared. Yeah.
Okay. The other group had needed a little more time.
Yeah. No, that's fine. We had very similar noticings and wonderings.
Oh,
Great minds think alike.
all right, I'll see you back. Okay, welcome back. I hope everyone had a chance to share out for both folks. All right, so in our next part, I'm going to open up both, but I'd like everybody in the Zoom right now, please. All right, so we're looking at my screen here. And so you're going to look deeper into those two graphs that you were looking at. All of you noticed about like the water tank and or the level of the water, right? And then the almonds and the figs, and that both of them had that same graph. I heard the words decreasing. I heard in one of the groups negative slope. And so thinking about what those words mean, we're going to put it into context now and see how those graphs are directly related to these equations here. And so in screen 16, you'll see about the water tank. And then in screen 17, you'll see about the almonds and figs. And so I want you to work with your partner to answer those questions that are there. I'd like you to see how they're connected, the graph with the equation. And so I'm going to give you 8 minutes to work together, and I'll be moving around the rooms. All right, so let's go back out to those same rooms. 8 minutes. Oops, forgot to change the time.
You're muted, Joy.
Thank you. That has happened to some teachers where they're just like, and then they're muted, and finally a student tells them, all right, I think we're missing, no? Is Allison here? I couldn't. There you are. Okay, cool. So I'm going to ask two of you to present your thoughts on the second problem there. So first, I'd like to invite Claire. Claire, would you share with us your thoughts on how you saw the equation and the graph linked together?
Sure. So Because the sentence at the beginning said that the equation would represent the relationship between almonds and figs and the dollar amount Claire spent on them, I knew that that 75 at the end must be how much she spent in total, which told me that 6 and 9 are the prices of almonds and figs and are not necessarily going to appear on the graph. So it makes sense that my classmate might have been confused.
And how are you able to see it?
So Nareen and I chose a couple of examples of points on the graph. So for instance, we put on one of these purple points, we chose 2 pounds of almonds aligns with 7 pounds of figs. And then I typed in my math equation at the bottom. So 2 pounds times $6 plus 7 pounds times $9 would be a cost of 75 total dollars. That was one of the examples, and it worked for other coordinates too.
All right, thank you, Claire. So you and Noreen chose points to check out that the equation was indeed working. All right, thank you. Next, I'd like to invite DJ up. Can you tell me what's happening here in your drawing, your sketch?
Yeah, so we were looking at the previous slide and about how the vertical axis was like when we started measuring how, you know, how high the tank was when it started losing water, like before it started losing water. And we noticed it touched the vertical axis at a certain point, and we were able to see that in the equation. So when we looked at our equation, we realized that it wasn't in the same form. Like before it was like A is equal to, and the A was representative of the vertical axis. So we wanted to, I guess, manipulate our equation to where our vertical axis was represented. And we figured out that that would be the dry figs. So when we move stuff around, we solve for y. And then we had it, when you solve for y, you get, well, you start to get the 75 divided by the 9, which is 8.3. And then you can see that in the, like where it hits the vertical axis right there. And then we were gonna, I mean, we were gonna measure the rate of change to see how we could see the second part of the equation, but we didn't get that far.
All right, thanks, DJ. May I ask you to help us see how to get to that equation there? So I'm gonna just set it up, and I'm using my finger and my mouse pad, so I'll be a little slow. All right. Can you tell us how to get there?
Yeah, you're gonna minus 6x from both sides.
Okay. All right.
And then you're going to cancel the 6x's out.
What do you mean by cancel?
Oh, well, you're gonna eliminate it. That means, yeah, you can draw a line right through it. If you had 6x and you lost 6x, that means you have 0 x's. So
All right.
I guess they just go away.
Thank you for the 0. Okay.
And then we still have 9y left. And then that's going to be equal to negative 6x plus 75.
Oh, sorry, I need to upgrade my tech. All right. Oh.
And then we divided both sides by 9.
Okay. All right. So what do you get then?
Oh, yeah, you get y is equal to, and then this is the one we got negative, let's see, I'm going to do 2x over 3.
Okay.
And then plus 8.33.
All right, you divided that one. All right, thank you. All right, so I'm hoping, could I get a thumbs up if you can see that 8.33 that DJ was talking about on the graph right here? All right, nice. Thank you so much, DJ, and thank you, Claire, for your thoughts as well, because both of those are absolutely valid in seeing the connections between the equation and the graph. And I am hoping, though, that everyone can see that by changing it into this form, which we learned was the slope-intercept form, we can see the direct links to the equation and the graph. All right, so keep that in mind as we move on to our next activity. And end scene.